Let me explain here. So I come from the enterprise. You may remember us from the far right column of the pricing page that you have to send emails to understand more about. Why that's important, right, is because like many enterprises, I have a bunch of software, some of which I wrote myself, some of which I didn't. And that makes sort of following all of the LASCON advice that's come about the past couple days not so easy. I have to do some tricks to make it happen. This is Shannon's slide from the opening keynote. She says, well, if you're stuck doing stuff on the right-hand side, just dealing with deploys and monitoring, you're in trouble. Well, so this is kind of a talk about how you can still architect things well if that is kind of where you're stuck. But you have to get a little bit creative with how you use identity and authorization. So it was a good kind of kicking off point. Also, really good talks related to this. If you saw Michael Schwartz's talk on Glue, or Prabhath's talk on from WSO2 and OAuth earlier, probably do some callback references. So you can try and take what they did and balance it a little bit with a bit of a custom review and a bit of practical detail around how we integrate those things in the real world of a large, 1,000-person financial institution. So the deal is when I'm stuck with products like this, I want to. I need to protect the environment they live in. They're not mine, and so the natural thing for me to do is wrap them in a hard perimeter, right? Build a system that looks like a castle, one giant wall, and assume that when you're on site you have it, and when you're off site you don't have access to the castle. If I want to buy a SaaS thing, it's please fill out this 300-question vendor questionnaire. I want to send a road warrior out into the big scary world. We'll slap a VPN, maybe BitLocker or some other file encryption, and just hope and pray that everything is successful. But of course, that's hasn't been tenable for a long time, right? I have to manage this transition well, where each application manages its own security, whether I wrote it or not, where the devices and access points that people use to access my data wherever it lives are secure. So everything is managed end to end, and I don't lose anything, even though I can't have a single castle wall anymore. So Google actually described this really well. This was a 2014 paper they published. They called it BeyondCorp. They were certainly not the first to come up with it. As my boss reminds me, Whitfield Diffie was talking about the end of perimeters in the 80s. But they really published this pattern really well, and it's one that I find is really applicable. And what it basically says is that instead of relying on location from the sense of inside a perimeter to grant you access and trusting VPNs to virtualize your perimeter when you have to, go ahead and build your access so that it's based off user identity, mechanism of authentication, device credentials, environment details, location, the thing being accessed. So if I leave you with one thing, that is the thing I want to leave you with. As you architect your application, or as you architect your framework, especially if you're working on open source software, try not to architect your applications in such a way that permission is a function exclusively of user identity, or maybe of groups. It's a function of attributes of the user that come with the user authentication time. So things like device, things like location, things like context. Ultimately, it's attributes of the session, right? Not of the user. So again, you're doing this already, even if you're not doing anything fancy with SAML and OAuth. You may not realize it, but you are if you're running your applications where they're only accessible behind a firewall, or they're only accessible from certain devices. You're just managing it with physical security, and you're managing it with network security. Let's manage it in a better way. So what I'll cover kind of in the next 30-ish minutes. Quick recap of what enterprise infrastructure looks like. I know this is an AppSec conference, so I'm not sure how many full-time blue teamers there are, although a lot of pen testers here, so I imagine most of this won't be huge news for you. I'll walk you through kind of the components of the paper. Then I have a bunch of demos and code that I want to show you of how we're implementing this pattern. But ultimately, let me be clear with you about where I am. This is one of those talks where I'm pretty sure this is a good idea. We have it working in prod a little bit. But before I go too far with it and lock myself into something that is unique and crazy, I want feedback from the community. So hope we'll get that from you guys. It's really I've worked on the puzzle, and now I'm looking for feedback. So brief recap, enterprise infrastructure for AppSec people. So obviously, the most important and fundamental thing about security is knowing what my assets are, right? So I classify them, in a sense, as BeyondCorp would recommend, into tiers. There's the things I barely care about, and all the way up to the things that cause me to wake up in the middle of the night screaming when I think of a new vulnerability that exists to them. And while the data that I care about is organized into tiers like this, unfortunately, my applications often aren't. And so I have to protect applications that contain the sensitive things, which often is, unfortunately, a lot of my business logic, a lot of my client PII, and a lot of my company operating details at the level of the most sensitive thing they contain, which often means that I am overcomplicating the design of more sensitive pieces of my infrastructure. I would like to not do that, right? It's about managing my risk well. It's about not assuming that the sans critical controls, or whatever control framework is your favorite, is equally appropriate to everything in my infrastructure, because a lot of controls really make UX bad, right? If I have to run everything through a proxy or AV break certain things. So I want to pick the right controls for the right set of applications or data that's going to be accessed. Sometimes, if it's the most sensitive stuff, like root keys, those controls are going to be really onerous. And sometimes they're not. When they're not, I would like to give people a little bit more freedom. So the tools that I use to do that, again, in addition to AppSec controls, are often perimeters, right? As application developers, you're not unfamiliar with perimeters. They're a part of your design. You slap them in front of containers. At a minimum, you're probably throwing an ELB or Elastic Load Balancer in front of things. Maybe security has talked you into putting a WAF in front of the application, whether or not you know what it's doing, whether or not they ever show you the logs of it. You're probably pulling your logs from something other than your application in addition to your application itself, if only for performance testing and debugging. So you're already used to the notion of separation of duties in a security sense, where your perimeter and your application are jointly responsible for protecting the thing. You probably, if you're an AppSec developer, are not thinking at all about the outbound perimeter. What lives between this device and all of the myriad ways that it's going to get compromised, especially if you're a developer and installing random untrusted software from the internet, and what's happening to the internet. You may not be thinking about that, but at an end-to-end risk level, it's really important to me that we're doing it well. And so I have a number of things that perimeter is doing for me that I need to find another way to ensure are happening well. So simple firewalls, make sure people aren't just sending things in, logging kind of what kind of accesses are to look for indications of compromise, maybe malware protection, netflow logging and see what's going on, DLP if I'm sort of truly advanced, looking for specific badness that might be leaving the perimeter. All of those things I want to live outside the device in a way that says even if the device is compromised, I get some visibility into what's going on. And then there's things I want to do to the device itself. I want to make sure that configuration is happening well. I want to make sure that we're doing host IPS or something, again, like it, appropriate to the device and the sensitivity and the risk of the thing that I'm trying to protect. Basic controls, right? When I had a physical castle and I was protecting a physical castle with physical walls, I could be fairly confident that the thing living under someone's desk was being managed in this way. When my devices are moving around and my servers are moving around, as they are, I have to get creative. And the best tool there is the identity ecosystem. BeyondCorp basically provides a pattern for using the identity ecosystem, SAML, OAuth, Ping Federate, Azure AD, as well as the directory tools I have in my enterprise already, to verify that these other controls, these perimeter controls and these device controls, are in place and operating well every time one of my applications, or frankly, one of your applications is being accessed. So identity, to be clear, is not just a matter of knowing a protocol or two. It's a governance and integration problem. It's about knowing who your identities are, managing it when people leave the organization, but it is for sure also a tech problem of tying users to service accounts and getting a fairly complex set of tools to work together. So here is the BeyondCorp architecture. This is the slide, or this is the design at the very top of the paper that I referenced, and then they reiterate it in the paper that came out 2 years later. What it recognizes that most of the enforcement of these controls can be done behind the scenes if where you aggregate the data that's coming from other network and application signals you do have available to you, the device if it comes on site ever, the reporting that the tools that are installed on the device, your monitoring tools and your configuration management tools are providing, previous authentications and other activity that the user is performing, and you can feed all of them together to build a picture of how much you trust the device that is as good as what you could do with the perimeter in place yourself, and feed all of that information fundamentally into an access proxy. So a thing that you wrap your applications in that checks the risk of the application that's being protected or the data that's being protected, as well as the status and everything you know about the person, the device, the location that are trying to perform that access or perform that action, and then says, thumbs up, great, thumbs down, no, I won't let you do that. Pretty straightforward, right? It's how you define a policy enforcement point. The obvious one here is WAFs, or any sort of the old term web access management is a similar thing that does this. The API gateway is doing something like this as well. So I don't want to claim that there's any magic in the policy enforcement point. It's what's going on behind the scenes and the logic it has to do. It turns out there's no one thing that seems to do this well. Recap how SAML works, and we'll show how SAML plays into this ecosystem, right? What SAML does is it separates out the policy enforcement point. This is your stuff. This is the application that's making access decisions, who can and can't have access to what, to some extent from the policy decision point. This is the identity infrastructure ecosystem that learns about you and decides how it works. So if you're not familiar with SAML, basically I try and hit the application. Application says, hey, you're not authenticated. It does a redirect via HTTP post to me, the identity provider, or IDP. The IDP usually is going to ask me via the web for my username and password, but it can do a bunch of other things, and then redirects me again via HTTP post back to the policy enforcement point, back to the application with a SAML ticket. That SAML ticket says, hey, I now have the identity of this user. Do with it what you will. OAuth authorization flow, very similar to this. So while I'll probably demo stuff with SAML, I think one of the most important things to me is how we get this to work in an OAuth world as well. SAML being an ancient technology, in fact, sends a whole bunch of things in XML. The important thing, of course, is the user. That's what everyone uses, right? They use the identity. But you can actually include a bunch of other attributes in that can be fed into your application, that your application can use to make good decisions. And this is what I'm really pushing the other developers I work with to respect, and this is what I'd like you guys to start thinking about how you can do it. So where did those come from? Well, my IDP normally just talks to LDAP, right? Normally, an identity provider pops up a web page that asks for your username and password. If you get your username and password right, it issues the SAML assertion. If you don't get your username and password right, it blocks you there. But why would I stop there, right? It's an easy place to plug in an MFA check, and many users do that. Duo has sort of a SAML provider, as do OneLogin and a bunch of other guys. The next most important thing for me to do is protect my device. So laptop has a TLS cert on it installed into my browser. That uniquely identifies my device and allows SAML to validate all the things it knows about my device on the back end from my configuration database. Look for what's been going on with my device lately to verify that independently in addition to me. And then, of course, I can do other basic checks, right? I have certain restrictions on what can be done for legal reasons or otherwise, must be done within the US, limitations on what can be done in other parts of the world. And so I can use my identity provider to enforce those restrictions, again, even if I have an application that isn't mine, doesn't live behind my firewall, lives elsewhere, so long as they speak SAML. And most of the time, more and more applications do. When they don't, I am forced to build an app proxy. So build my own API gateway. The other use case where I have to do this is that SAML is all or nothing, right? Once I have issued the token and authenticated to the application knows I'm logged in, keeps me logged in, and allows me access for the duration of that session. But if that application contains multiple levels of data in it, and I want to say, grant me access to sensitive or simple things, but not access to sensitive things, I have to rely on the application's ability to do that. Most applications don't. And so in those cases, I have to redirect people through a proxy and rely on the proxy to enforce those limitations. So that's where we are, right? So let me kind of, so this is, it's not an ideal design, right? In this case, my proxy still needs to understand a lot of the internals of the application. And if the application behind the proxy changes its design, changes its URL scheme, it gets ugly. So let's demo those things and kind of talk about what it took to get them working. And this is really where your advice on what to do differently would be very relevant. So why did I build things myself in any way? Well, first of all, like anything you're going to build, you have to understand the flow. I want to understand how all of these pieces work together. And I'm a bottoms-up thinker. That means I need to see things built out, turn on Chrome Developer Console, really watch it happen to understand what's going on. But I am a security engineer. I am not a developer first and foremost. And that means that ease of getting started is important. I want to stand up things that will fit well into my development ecosystem. And unfortunately, a lot of these tools assume that you have a lot that you're going to integrate with. So your own AD infrastructure, your own MFA infrastructure, your own configuration management database. I don't want to pick one vendor. I need to understand how those pieces fit together. And so being able to easily get started with both an individual component and a whole end-to-end auth infrastructure that already exists is really important to me. And the last one, and this is where a lot of security tools are weak today, and I think I'm not the first person this conference to say it, is that if I'm going to put this thing into production, it can't be manually set up. It can't be manually run. I have to be able to have a dev, a QA, and a prod instance. I have to be able to manage this thing through APIs and configuration throughout its life cycle. And so a lot of tools, unfortunately, I have to reject from consideration just because they don't really fit these criteria. And that meant I wrote some stuff and reused some other stuff. So let's take a look at that SAML thing, the basic test and issuance of those assertions, and some of the gotchas that came with writing that into a Django application, which is relevant to some stuff we do on site. And now is where I figure out where this multi-monitor setup works. So, all right, looks like, let's switch to mirrored desktops and see if this works. Nope, okay. All right, so, can I do that here? And I'll have to end up staring at the big screen. And make that a little smaller. Really simple, two things, again, running in a Docker container. Primarily here we have a Django application that's going to consume SAML assertions and make some interesting decisions based on what's in them, as well as the database required to run that. Remember, one of my requirements is getting up and running is really quick. Getting value is quick. Being able to deploy multiple copies of this is quick and easy. And so this pattern of having as much possible running in Docker is pretty relevant to me. Not HTTPS for today's demo. Let's make it smaller as well. Work, okay, good enough. Django's model is very user-centric, and it's one of the things that makes life difficult for me, right? I have details of a SAML session. Oh, I'm actually already logged in. Is this sign out going to work? I don't know if it will or not. Nope. All right, so this thing, logged out of the IDP, the session is still here. So it's a little bit out of date, but that's fine. I'll be able to make my point effectively. So these are the things that came out of, let's do it this way, sorry. Can I start up a new Chrome? That should actually do it for me. Probably still failed. Okay. There we go. So anonymous, sign in, does the redirect to my identity provider. Identity provider is mine, right? It's hosted in my infrastructure. It's not hosted in. It's not owned by the application. Redirect back, and now I get all of these information about what I am. Those things are now stored in the session. They're not stored in the user, and why that's a problem for me is that some critical features that I would like to implement in Django, all of these models, this is staff and is super user thing, I would like to restrict these to only be done from secure devices and while on site, right? But it's within an application, so I'm reliant on Django's model, which is normally tied to a user is a super user or a user is not a super user. And so the traditional way to manage this pattern is to create a Aaron Zollman account that is not a super user, and a second one, Aaron Zollman SA, who is. But then I'd still have to write policy that restricts the Aaron Zollman SA account to be used from certain locations and certain devices. I do have code that gets around this. And if I get back to PowerPoint, it kind of looks like this. Happy to share it with anyone. I'll open source it in the next couple weeks, I hope. But it requires me to do janky things that I don't like doing. So I actually had to write my own user middleware for Django. I don't know if you guys are Django people, but middleware is something that processes every request and changes the state of the application. So I wrote my own user object. I wrote my own SAML middleware. And it really just catches all is super user calls and checks them against the value of the session. It is super hacky. I do not like doing this. But if the alternative is writing my own authentication model from scratch, I'd rather shim the one that exists. It's more likely to be able to be deployed into the applications that I already have than if I have to ask every development team that's written a Django app to rewrite their application with a new model for role-based access control. Okay, so that's sort of one pain we ran into trying to implement this model, where the application uses its own model and is tying permissions to the user. So second thing I said I would demo is the app proxy flow. So here we built some stuff out in using Nginx, using Shibboleth, using, again, these same tools that are used for building integrations with APIs on site and scaling them out. But now we're adding a little bit of respect for some of these extra assertions and deciding what we're going to do. And so I'm able to implement it as part of my Nginx conf file. This is not as scalable or as useful as one of the patterns that, for instance, the WSO guy was talking about, where there's these languages for extensible access control called execml. That's the direction I'd like to go. But today, I'm literally writing URL filtering code based on certain locations in Nginx code, and at least it gives me something. where I'm able to consume these assertions and limit sensitive operations even within applications without modifying the application itself. So how does that work? Demo. So this is another set of Dockers, right? So three components to this application. Three components to this application, right? So there's the Docker, or excuse, there's the Docker that runs the proxy, which is Nginx. There's a Docker that's running Shibboleth, which is an SP, and there's a Docker that's running a backend application. And because for these demos, I actually like to kind of expose the meat of how this is working in the hopes that you guys learn the same way I do. Let's go ahead and bring up another thing, and I'll show you the world's simplest application. So normally I would run my application behind a firewall so that I can't forge headers to it, but today I'll show you, again, the world's simplest application. All I'm doing is exposing the headers that this application gets to show that backend applications don't need to be that smart, to show that backend applications don't need to understand SAML, don't need to understand OAuth to consume things if there's a proxy in front of them that's doing a lot of the hard work for them and passing them tokens or details about the authentication. So rather than access that directly, we'll go through the proxy, which is running on localhost 443, and you can see this whole flow, theoretically. All right, tell you what, we're going to reboot everything. Demo gods. So starting those three applications takes 15 seconds, part of the things that I really care about in building a project. There we go. So you can see the first thing it's going to do, again, because this is the first time I've done this, it's asking me, hey, are you sure you want to send your device certificate to this proxy? Because it's going to use that to authenticate you. Is this the right one? Yes. Redirects me to the IDP. IDP is going to once again ask me for username and password. IDP does a second check on my device certificate, right? Because I want the same device that was doing the login to be the one that's being checked at the API gateway. And my backend application now gets, I can do enforcement either with a proxy and also pass details back to the backend application. So you may be familiar with this pattern. Again, if you're Django developers, or if you've deployed Splunk in SSO mode or Jira in SSO mode, this is a very common pattern that my proxy puts a header called remote user, and the backend application says, oh, that's the username, I accept it. Traffic came from the trusted proxy IP address, therefore I will allow this to proceed. The user doesn't have to log in. I trust the value in that header. But the limitations to this are, it's just a username, right? It's the same thing, the same pattern that I want to get away from, where I'm making application decisions, or I'm making backend decisions. I want to make those decisions based on more than the user. And in this case, sort of as promised, I have sort of a, any normal locations get through, but the ones that are designated for on-site only are going to give me a 403 because my Nginx proxy is blocking that, not because the application is smart. The application is profoundly dumb in this case. So those are the demos, basically. Again, showing that we're kind of at this place where we're starting to make much more granular access decisions. And as I do this, as applications are shown to either work behind a proxy that allows me to manage them this way, or they're shown to work behind a proxy that allows me to manage them this way, or I can get the application developers for my in-house applications to refactor their applications to understand these special assertions, or I can configure the rules within my identity provider and have the enterprise applications, the SaaS applications that I work with and buy from, understand these restrictions and not allow people to use them if they don't respect my session timeouts and SAML tokens, I'm actually able to give my developers and my users much more freedom. Let them operate outside the walls, let them operate from devices that have a little bit of less control, because I know and have confidence that even if the device is secure, is less secure, even if the location they're coming from is less secure, I can limit them only to those applications that are appropriate to their current security posture. So where are we? What's left? I feel okay that we're kind of at this nebulous proof of concept, shown it for 2 applications, but not really everything in my enterprise space, because at least Google's been at this for 2 or 3 years, and they've had more time and more people to throw at the problem. Clearly there's a lot left for me to figure out here. The first thing is, did I pick the right model for my rules and attributes? So I said, okay, device status is going to have an enumeration. It's going to be either compliant, it's going to be known, or it's going to be unknown. And then I'm going to set rules based on that. It would be nice to write those rules once to tie them to the trust tiers, right? The more sensitive the application, the more compliant the device has to be. Now I'm implementing those rules in a hodgepodge of shim code within Django and shim code within proxies. It'd be nice to write them in business logic like Execml, but the only public project I could find for Execml was an Apache incubation project called OpenAZ, which was discontinued. And while Prabhath from WSO2 pointed me at another one about an hour ago, it's his project, so that's helpful. One project does not an ecosystem make, so I'm a little bit worried. Is Execml a tool to build on? Yep.
Yeah. So
Okay.
do you know UMA?
Yeah, OAuth UMA profile. So I'm looking into that.
Yeah.
So
So
we talked about
Execml
that.
is like it's old, right? Many years.
Yeah.
And it's very complex.
Okay. So
So UMA is probably
cool. Yeah. So so the whole sort of OAuth ecosystem is something probably been working on for only 2-3 months at this point. And so from the authentication of users and basic authorization, we can do that. It's naturally works really well with things that are already very API driven. A lot of the applications I have to port and protect are more web driven and more driven to the SAML flow. So I put my energy there first. Definitely sort of the next month or two as I get back to work, I'm going to spend a lot more time sort of looking at that implementation. Yeah. And then, I feel pretty good about this device cert pattern. It seems very similar to how Google is working. But man, it's still not great UX, and there's still a lot of management overhead with dealing with that particularly well. If anyone's done particularly interesting work with device fingerprinting, I'd be interested to hear that, right? I see it with things like Google and Facebook login that when it recognizes a new device, now admittedly that's just like lack of presence of a session cookie or a device cookie, but it recognizes a device or class of devices that it's not used to me working from, it throws up an extra auth. Pattern and code for integrating that into my workflow would be really helpful to me. And then a lot of the, one of the tools that's a lot of our developers really love for managing operations and managing short-term API credentials is HashiCorp's Vault, which luckily does speak OAuth. So integration patterns with those types of things, short-lived API creds and bootstrapping are things that I need to figure out as we build out kind of the API, fully API'd version of this thing. So that's kind of where we are. As I said, it's kind of it's a status report of in process, how we looked at our challenges as an enterprise and the patterns that people larger than us had built, kind of interpreted them through our own needs. Interested in thoughts and feedback. In the meantime, contact information and slides are out there.
Thank you.
Thanks.
Yeah.